Alright guys, in section 2 I'm going to introduce how to graph linear equations with two variables. Okay, so I'm not going to use slope-intercept form, even though that's what you probably want to use most often, but we're going to use instead of the x and y intercept. So first we need to learn what the xy coordinate plane is, the Cartesian coordinate system. Alright, that's what these are, and that's what that looks like. Okay, that's all it is. It was made by this guy named Descartes, who was real smart. Okay, so just the introduction to this. Okay, this is the x-axis. This is the y-axis. Okay, so as you move to the right, you're going in the positive x direction. To the left is negative x, bottom is negative y, up is positive y. Okay, and these are actually organized in quadrants. So 1, 2, 3, and 4. Those are the 4 quadrants that you're labeled. And that's the general idea of the coordinate system. All right, 0, 0. Here in the middle is called the origin, in case you need to know that. Other than that, you're in pretty good shape. Okay, so standard form for the equation of a line, all right, linear equation, is ax plus by equals c, where a, b, and c are just constants. They're just numbers. They could be positive or negative. All right, usually a is a positive integer, so a whole number. If it's not, it's still okay. It's still technically standard form, but usually you'll see that the one that leads the x, the first one, is usually a positive integer. Okay, some things that are not linear. Can't have any exponents, right? No exponents, that's not good. You can't be multiplying the x and the y together, that's not going to be linear, it's going to be a curve. And you can't have any variables in denominators, okay? So this also is not linear. None of these are linear. This is a parabola. This one's more of a hyperbola type deal. And same with this one, okay? So those aren't quite lines, right? They're not straight, they're curves. These special cases, okay, horizontal and vertical lines, all right? So if you don't have both an x and a y, then you're going to have either a horizontal or a vertical line. If you have just a y, then it's going to be a horizontal line, because we know that y is down at -6, okay, down -6. 1, 2, 3, 4, 5, 6, okay? But we don't care what x is, so x could be anything. We just want to know that y is -6. That's why it's a horizontal line. And vertical lines are just going to have x's in them. So we're going to go to the right, the positive x direction, 1, 2, 3, 4, 5, and we care that that's 5, but we don't care what y is this time. So y could be anything, right, as long as x is 5. Don't forget it, x vertical, y is horizontal. Now, finding the x and y intercept. Of course, you could just graph these on these planes and figure out where you could graph this line and figure out where it intersects on the x and y axis, and that would give you your x and y intercept, because that's what that is. It's where they cross the two lines. But an easier way to do it is, you know that if you are finding the x-intercept, what that means is that y has to be equal to 0, because if x-intercept is on the x-axis, that means you're not moving up and down at all. You're right here at y equals 0. Okay? Y equals 0. And for the y-intercept, that means that you're not moving side to side at all, so x has to be equal to 0. Okay, so you have something to plug in. You might know this as the cover-up method. Right? You can cover up the x's because it's just going to zero out in order to find the y's, and vice versa. Whatever method you want to employ works great for me. So to find the x-intercept, I'm going to plug in 0 for y. So 0 minus 2x equals 6. And divide by 2, or -2. X equals -3. So the x-intercept is x equals -3. And the y-intercept, I need to plug in 0 for x. All of that goes away, and y equals 6. X-intercept, x equals -3. Y-intercept, y equals 6. Very easy. Now, how to graph ordered pairs. Okay, so remember that the first is the x, and second's the y. Okay, so I need to move to the left 1, because -1 for x, and down 3 for y. To graph the first one. The second one is to the right 2 and up 2. The third one is to the right 4 and up or down 0. Okay, so those are those 3 points. Now, how to graph a linear equation. So one way to do it is to find the x and the y-intercept and then just connect them and put arrows on the end. Okay, so that's what we're going to do here. We're going to find the x-intercept first. X-intercept for x, y has to equal to 0, so you don't even need to write that stuff down. For x equals 12, and so x equals 3. So I could put that on there. X equals 3. That's the x-intercept. And the y-intercept is negative 3y equals 12, right? Because 4 times 0, when x is 0, equals 0. And y equals negative 4. So go down 4. There's our 2 points. Connect them. Something like that, but have steadier hands. Okay, draw your arrows, and that is that line. Now, number 4 is a little bit more difficult, right? So something like this that's not easy to find, right? You could still do the x and y intercept thing here, but it's going to take you forever. It would be a disaster, right? Something that isn't immediately clear to you. It doesn't look normal. So this one's got an absolute value in it. That's definitely not normal. I suggest you just kind of start with the origin, start with a 0, and then kind of work your way side to side, and hopefully you'll see the pattern. So for this one, I know if x equals 0, then y is also going to equal 0, because 0 minus the absolute value of 0 is still 0. So we have the origin. That's good. Now I'm going to go in the positive x direction and see if I can figure out a pattern. So if x equals 1, I've got 1 minus the absolute value of 1, which is still 0. Well, what about 2? 2 minus the absolute value of 2 is 0. 3 minus the absolute value of 3 is 0. So I'm going to assume that this is going to go on forever. I don't see any reason why that pattern would ever stop. So it doesn't matter. Anything in the positive x direction is going to be y equals 0. Now the negative x direction, let's try that. Right, when you plug in negative 1 for x, you got negative 1 minus the absolute value of negative 1. Okay, absolute value of negative 1 is 1, so you have negative 1 minus 1 is negative 2. So negative 1, negative 2 is a point. Okay, now you plug in negative 2 here, and you should get negative 2 minus 2 is negative 4, and you see the pattern there. So that is that graph. Another way you might see this is just with a table of values. Okay, so you could just do an x, y, t table. Okay, put your, usually if you do 0, negative 1, negative 2, 1, 2, right, that's usually enough. So you could work these out on the right side, and you would get negative 4, negative 2, 0, 0, 0, and you can see it from there. Okay? Last two is just a review quickly of what these special ones look like. Remember, y is horizontal, so you just need to go down 2 and go straight across. Bam. And x equals 3 halves. To the right, 3 halves. Oh, that's not 3 halves, that's 2. To the right, 3 halves. My stylus is too fat. Okay, that's really bad, but you get the idea. Go right 3 halves and make a vertical line. Remember, x is vertical, y is horizontal. Don't forget it.